Welcome back, guys. Today's video is on prime factorization. We'll begin by understanding prime numbers, prime factors, and then we'll learn how to express whole numbers as products of their prime factors. Let's get into it. Prime numbers. Prime numbers are numbers that have only two factors, one and itself. Examples of prime numbers we have displayed on the screen along with their factors. So you have 2, 3, 5, 7, 11, 13, and so on as displayed on the screen. So for each of these numbers you can see on the screen, they have only two factors, which is 1 and their self. Any other number you try to divide them by, you will get a remainder. Take, for example, 41. If we decide to say 41 divided by 2, we're going to get 20, remainder 1. The only numbers that can divide 41 without a remainder will be 1 and 41 itself. So here you have the first prime numbers between 1 and 50, and there are many more prime numbers. So that's what prime numbers are. Please take note of that. Now, prime factors are those factors of a given number that are prime numbers. For example, if you look at the factors of 30 that are listed on the screen, we have 1, 2, 3, 5, 6, 10, 15, and 30. But from all these factors of 30, only 3 of them are prime numbers, 2, 3, and 5. The other factors of 30 have more than 2 factors. For example, 6. What are the factors of 6? The factors of 6 will have 1, 2, 3, and 6 itself. So you can see that 6 has 4 factors. It's therefore not a prime number. We can do the same for 10, 15, and 30. You discover that they have more than 2 factors, so they don't qualify as prime numbers. However, 2, 3, and 5, like we can see on the list we made up here, we have only 2 factors, 1 at itself, so they are called prime factors. So when we do prime factorization, it's not just about identifying those factors of a given number that are prime numbers. Prime factorization basically has to do with expressing a number as a product of its prime factors, which is what we are going to be doing in this video. Look at the examples that we have on the board. Express the following numbers as product of their prime factors. So we have 31 and we have 30, sorry, and 81. So this is how you go about it. We are going to say 30 on our division line. And what we have to do is we're going to be dividing 30 by its prime factors. So there are a lot of factors that can divide 30, like I showed you earlier, but we'll only use those factors that are prime numbers. So we're going to be dividing 30 by its prime factors. Let's start with 2. 30 divided by 2 will give us 15. Now we move to the next prime factor, because 15 is an odd number and cannot be divided by 2. So the next prime factor or prime number we're going to be using will be 3. 15 divided by 3 will give us 5. And then we move on to the next prime factor, which is 5. And 5 divided by 5 will give us 1. So basically what we're going to do is we're going to keep dividing 30 or whatever given number until we get to 1, but we are only going to divide it using its prime factors. We're not going to say 30 divided by 6 and write 5. The reason we are not going to use 6 to perform this division is because 6 is not a prime number. So we are going to perform this division using only prime numbers. That is why it's called product of prime factors. So basically, to finish this, we would say, so therefore 30 is equals to, and then we are going to multiply these numbers we used to perform the division. That's going to be 2 times 3 times 5. And you can check to see if you did correctly. 2 times 3 is 6, and 6 times 5 will give us 30. So we know that we have correctly expressed 30 as a product means multiplication, of its prime factors. So that's how you go about it. Moving on to the second example that we have here, 81. We follow the same process. I'm going to write 81. And then we have to divide 81 by its prime factors. And of course, 81 is an odd number. So we're not going to be starting with 2. We'll start with the next number, that's 3. 3 is a factor of 81, and 3 is also a prime number. And when you divide 81 by 3, you're going to get 27. And like I always say to my students, if this division is something you cannot do straight up, it's okay to come to the side and do your division here. And say 3, 8 to 8, you're going to get 2, remainder 2, and 21 divided by 3 will give you 7. That's how you go about the division. Take your time. The most important thing is that you get it right. Now, the next factor we're going to use here to divide 27 without a remainder will be 3 again, because 3 is also a factor of 27 here. And when you say 27 divided by 3, you're going to get 9. And what's the next factor that we're going to use that can divide 9 without a remainder? That would be 3 again. And 9 divided by 3 will give us 3. Next factor that we can use will also be 3. And 3 divided by 3 will give us 1. At this point, we can stop. So this goes to show that you can have instances where you use different factors like our first examples. And you can also have instances where you use the same factor throughout, like in our second example. So to express 81 as a product of its prime factors, we are going to say, so therefore 81 is equals to 3 times 3 times 3 times 3. And let's try this out. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 will give us 81, which goes to show that we have correctly expressed 81 as a product of its prime factors. Let's take 2 more examples on prime factorization. We have 98 and 120. Like we did in our previous examples, we're going to write 98. And because 98 is an even number, let's start with 2. We're going to say 98 divided by 2, and we'll get 49. Again, feel free to do your division on the side if that's not something you can do straightforward the way I've done. But we have 49. What's the next factor that we can use to divide 49 without a remainder? And that's going to be 7. Can use 7. 7 is a factor of 49, and 7 is also a prime number. And 49 divided by 7, of course, we know that's going to give us 7. 49 is a perfect square. 7 times 7 gives you 49. Again, what's the next factor that we're going to use to divide 7 without a remainder? Of course, 7 is a prime number, so that's going to be 7 itself. And 7 divided by 7 is going to give us 1. We've arrived at 1 and we can stop. So let's express 98 as a product of its prime factors here. We're going to say, so therefore 98 is equals to 2 times 7 times 7. And you can always check to see if your answer is correct. 2 times 7 will give you 14, and 14 times 7 will give you 98. And for our last example, we have 120, also an even number. So we'll start with 2. 120 divided by 2 will give us 60. Again, an even number, so we go with 2 again. 60 divided by 2, that's going to give us 30. Still an even number, so we can use 2 again. 30 divided by 2 is going to give us 15. And now we have 15 at odd number. We can't divide it by 2 without a remainder. So let's move to the next prime factor, which is 3. 15 divided by 3 will give us 5. And of course, to reduce 5, reduce 5. 5 is also a prime number. 5 divided by 5 will give us 1. And we are done. And we're going to say, so therefore, 120 is equals to 2 times 2 times 2. That's the numbers that we have here. Times 3 times 5. 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, and 24 times 5 will give us 120. So that's it, guys, on our lesson on prime factorization. If you enjoyed this lesson, please check out our next video on index form. And as always, I've got a bit of classwork here for you to do. Express the following numbers as product of their prime factors. You have 12, 27, 45, and 80. Feel free to submit the email on your screen, mathswithmrsspace@gmail.com. That's it, guys. Thank you for watching. Please do it to like, share, subscribe, and turn on our notification so that you know when we upload a new video. I'll see you in the next one. Bye.